Right, in this video, we are going to cover Chapter 11, Part 1 on dot diagrams. You don't have to look at this video already since I'm going to be going through the contents in this current video. So a dot diagram, this is an example, it's made out of a lot of dots. So this is a representation where each value in the data set is represented by a dot above the value on the number line. So our number line is over here, and you can see our values are shown here. So when a value appears more than once, the dots are stacked. Okay, so just for an example, here we have 1 timing 10.1 seconds. And then for this person, he ran the timing of 10.2 seconds 3 times. There was once he ran a timing of 11 seconds. Maybe he was sick, maybe he was unwell on that day, because most of his timing between 10.1 to 10.7. So if you remember, this is what we call an outlier. So a dot diagram shows how numerical data is distributed on a horizontal number line with equal intervals. So the spacing between these values are constant. So for example, we can determine whether the data is clustered around certain values or if it is spread out evenly. So in this case, we can see that the values of the data between 10.1 and 11, 10.1 is the minimum, while 11 is the maximum value. So if you remember, range is found by taking maximum minus 11. So our range here is 0.9 with the unit seconds. That's if you're asked to find the range value. Then we see that the data clusters is grouped very close to around 10.4 seconds. So how do you choose 10.4? You see all these values, they're all near 10.4. Usually it is somewhere in the center and it has the highest frequency. So we call it the mode as well. So the data is visually grouped around 10.4 seconds. And then we see a large gap over here. The largest value, 11, it deviates from the others, and therefore it's called an outlier. Okay, let's look at example number 1 over here. So we have the scores of some students in the quiz, total mark 20. So we can see actually the maximum was only 18 marks. Nobody scored 19 or 20 marks. And the lowest mark was actually 4. Nobody scored 0, 1, 2 or 3. And the question said some students. We can actually count to see how many students took the test. So currently they didn't ask quite enough, but I'm just curious. So 3, 1, plus 2, 3, 6, 7, like 10, 10 plus 1, 2, 3, 4, 15 already, 17, 18, 19. There are 19 students who took the test. So first part A, write down the mode. So the mode, we're looking for the highest frequency. Over here. So visually you can see very quickly, oh, the mode is 12 marks. And then in part B, calculate the mean. So no difference. Remember your formula for mean, x bar, or you can just write mean. So the formula, your summation fx, you don't have to write down this formula. I'm just trying to remind you over here, over summation f. So the first frequency multiplied by the first data, we have 1, 4. So as I've always been saying, you don't need to write 1. The next frequency, we have 2 5s. Then we have 3 6s, 1 7, 3 11, 5 12s, 2 13s, 1 14, 1 18. All the 1 you don't have to write them down. So divided by, just now I counted, there were 19 of them. Okay, so put this in your calculator, you end up with 190 over 19, which is 10 marks. That's our mean. Now in part C, they ask us to describe the distribution of the test scores in 3 ways. Okay, so the first thing we can say is that, well, the data clusters around 6 and 12. You see that? We have one cluster over here, we have one cluster over here. Somewhere in the center, we have a mode, so that is 6. Somewhere over here in the center, we have a mode of 12. So our first description, the data clusters around 6 and 12 marks. Okay, what else can we say? The data values are between 4 and 18 marks. You can also say the mode is 12 marks. There are many acceptable answers. You can also say there is an outlier of 18 marks. Now in example number 2, we have the timing for 100-meter sprint for students in Group A. How many students are there? So we have seen how we do this. Just count the number of dots. 1 plus 3, 4, count. Turns out we have 20 students. Calculate the range. So range, take the maximum minus the minimum. 11 in this case. Wow, another outlier. Minus 10.1. Actually, this looks like the example earlier. Okay. So we get our 0.9 seconds. Now they tell us that the fastest 20% of the students qualify for a competition. Find the maximum. Okay, it's a typo over here. Should be maximum. Because we want the fastest people, right? So we want people with very small timing. We want the top 20%, the shortest 20% of the timing. So 20% of the students. So we write down number of students who qualify. 20%. So 20 over 100, we have 20 students. We are only looking for the top 4 students. So who are the 4 students with the shortest times? So this is number 1. This is these 3 over here. They are tied for the second place. So there we have it. We have the top 4 students. And then the maximum timing is actually 10.2 seconds. If you run a time of 10.3, sorry, you're not in the top 20%. You don't qualify for the competition. Now in part D, it says that the students who took longer than 10.5 seconds, they need to run again. So what is the percentage of students who need to run? Then we need to find out how many of such students are there. For 10.5 seconds, longer than, So 10.5 is fine. Longer than 10.5. We've got these 3, 4, and 5 people. These 5 people, they need to run again. What is the percentage? So right now percentage, 5 students out of 20 times 100%. So that gives us 1/4, 25%. Now the same data is going to be represented on a pie chart. They want the angle of the sector representing students who took 10.4 seconds. So in a pie chart, it looks like a circle with a total angle of 360 degrees. So those who took 10.4 seconds, we have 1, 2, 3, 4, 5 of them. So the angle will be 5 out of 20 people. Instead of multiplying by 100%, total is 360 degrees. So put in your calculator, if you can do it mentally, it is just 1/4, right? So 90 degrees. Part F, find out the model time. The highest frequency, it is 10.4. Just by looking at the diagram, visually, you know that highest frequency is 10.4. So model time, 10.4 seconds. Find the median. Okay, now we need to look for the middle position. With 20 people, the middle position is 20 plus 1 divided by 2. So we are looking for position number 10.5. Meaning we look at the time for number 10, the time for number 11, and we take the primary school average, otherwise known as the mean. So let's find number 10 and number 11, starting from the smaller value. So this is number 1. Number 2, you can either start counting from the bottom to the top or top to bottom, it does not matter. I just stick to whatever you choose. So I like to start from the bottom. So number 1, number 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is position number 10. Position number 10 has a timing of 10.4 seconds. Position number 11 also has timing of 10.4 seconds. So what is the mean of 10.4 and 10.4? It is going to be 10.4 again. So conclude that the median is 10.4 plus 10.4 divided by 2, so you get 10.4 seconds. Now in part H, calculate the mean time. Just do it now. The correct answer will be 10.42 seconds. So if you don't have 10.42, please check your work again. Then in part I, which is a better measure of the average of the data? Do we use the mean or do we use the median, and why? So for comparison between mean and median, you always check, is there an outlier? Because if there is an outlier, then the mean is not a good option. The mean will always affect the outlier will always affect the mean. So if you see an outlier, don't use the mean. Instead, you use the median. So just now we saw that, there is an outlier, it was 11. So instead, 11 is an outlier. Think about it. If we don't have this, our mean will be lower. But now we have this outlier. It actually pulls the mean up. it increases the mean. So the median, as a measure of the central tendency, will be able to exclude the effect of this outlier. Okay, so we have not completed our explanation. 11 is an outlier. It will increase the mean. Median is a better measure. Okay, so put a star for this. Very popular question. In fact, it almost always comes out. So next one, also very important. Now we have another group of students, group B, median 10.5 seconds. Okay, so earlier we had our median in group A 10.4 seconds, so we can do a comparison already. Then we also have mean time 10.6 seconds versus our 10.42, but we already know that 10.42, this value is not a good representation because there was an outlier. So we shouldn't be considering the mean. And then we also have a range for group B, 0.7 seconds. In this case, we had a range for group A, 0.9 seconds. Okay, so later, we will answer this question by comparing the values. They say compare and comment on the timing of these two classes in two ways. So this is a very important question. You must be able to answer it in the following format. We're going to compare the median. Okay, we don't want to compare the mean. So we write down for the first one, they wanted two ways. The first way, median of A. So you put a small a at the bottom. Median of A. And I need you to state the value, 10.4 seconds. Compare it with the median of B, which is 10.5 seconds. So which one is bigger? Which one is smaller? So 10.4 is less than 10.5. This is your evidence. Then you must state the conclusion. Since the median for A is less than median of B, we say that, therefore, students in group A run faster. We're saying that they are generally faster. Not everybody is faster, but generally, students in group A run faster than in group B. So that was our first conclusion, first method for comparing. The next thing that we want to compare is the range. So state range for A, we calculated it was 0.9 seconds. Range for B, it is given to be 0.7 seconds. Now, range for A is big, range for B is small. Our conclusion. The students in group B, they are actually more consistent. The values are all closer to each other because the range is smaller. Whereas in group A, the range, wow, it was so big. It was due to that outlier. So if we didn't have that outlier, our range is actually 0.6, wow, even more consistent. So this outlier really is causing a lot of problems for the rest of his students in the group A. So now, when we compare range, we talk about consistency. Group A's timings are more spread out. Okay, they are more spread out than group B's timings. Alternatively, we can say that group B's timings are more consistent than group A's. Okay, so just a note. Consistent is opposite of spread out. Use range. Use the range to determine consistency. To check to determine consistency. CONSISTENCY. For everything else, you either use the mean or the mode. If there is an outlier, you use the median. If there's no outlier, either the mean or mode or the median will be okay. Okay, so now your work to complete example number 3. So everything we have done before already. Example number 4, we have a case of back-to-back dot diagram. Basically, we are just trying to put two sets of data very close to each other such that they share the same number line. So on top, we have the dot diagrams for male students. Okay, this is the masses. So at a glance, comparing the male and female students, I can say that actually the males they are heavier than female students. Because male students, their masses are clustered more towards the right. Okay, so complete this question. For your homework, do this. Or if you have time now, you can also do it in class. Likewise, this is also your homework. So you don't have to do this textbook, I just do this particular question. And that's all for this set of notes.